Hello class, welcome to Pre-Algebra Lesson 8.2, which is all about proportional relationships and slope. By the end of this lesson, you should be able to graph and compare proportional relationships using words, equations, and tables, and interpret the unit rate as the slope of a line. Okay, so let's quickly talk about proportional relationships. So a proportional relationship is when you have two different quantities, two different numbers that are they are proportional if they have a constant ratio or unit rate. Okay, so meaning like, look, if I look at this table, okay, my x's, they're going up by 1, right? Going up by 1, going up by 1. My y's up by 3, up by 3, up by 3. So in order for something to be proportional, all of your x numbers need to match, and then all of your y numbers need to match, okay? Your x and y number doesn't have to be the same. So even though this is a 1, your y doesn't have to be a 1. It just needs to be that all of your x's, so 1, 1, and 1, that those are all the same. And then down here, 3, 3, and 3, that those are all the same. If you have, let's say, a 1, 1, 2, and then let's say you have like a 3, 3, 1 or something, that would be non-proportional. Okay, so one way that we represent that is we can say our information is proportional, our data is proportional, if y divided by x is always the same. So like if I look at this, y divided by x, y divided by x, y divided by x, I'd always get the same thing, okay? And then if you're looking at a graph, something's proportional if it's a straight line and it goes through the origin, okay? You need it to go through the origin. All right. So, oops, I forgot to delete one thing off this slide, so let me quickly take care of that. There we go. All right. So now let's talk about like what a rate of change is. So a rate of change is just the name for like what we call how much something changes by, okay? So if I look at this kind of example right here, we have the time to download songs as shown in the table. Notice that as the number of songs increases by 2, the time in minutes increases by 1. The unit rate is 2 songs per minute. Okay, so it's your y, change in songs, which we said was 2, over your change in minutes, which was 1. Okay, so something to really remember is that it's always y over x. Something else that we call it is rise over run. And another name for it is slope. Another name, actually, we'll leave it there. Another name for it is slope, okay? So these are all ways to describe the same thing. So rate of change is the same thing as y over x, as rise over run, as slope, okay? So if we look at this second screenshot, we have that same table from the last slide, and then you can see like we have a graph, and you can see that it is up 2, you can see the green, it went up 1, 2 units, and then it went over 1, up 1, 2, over 1, up 1, 2, over 1. So that is our rate of change. So if we look between 0.24 and 3.6, our rate of change is 2 over 1, or just 2 songs per minute. Okay, so usually when you're talking about rate of change, you're going to end up labeling your answer. And then if you're talking about slope, you would just say 2. Okay, so we'd say slope equals 2, or the rate of change is 2 songs per minute. So you want to make sure you pay close attention to what you're being asked for on the assignment today. You're going to be asked more for the rate of change, okay? So make sure you have your labels with your answers and whatnot. All right, now let's try an example on our own. What does this maybe look like? We have the graph shows the amount of money Ava saved over several weeks. Find and interpret the slope, then find the unit rate and compare it to the slope. Okay, so we just had talked about the slope. So we're saying how much it changes. Remember, y over x. So I like to start right at the origin because it's 0 for both x and y. Okay, so then how far up do I go in the y direction before I hit this first point? I go up 15. So I'd say 15 over, and then x, I went from 0 to a 1. So 15 over 1, or just 15, is our slope, okay? And what a unit rate is when you have a 1 on the bottom of your slope, okay? So anytime you have a 1 on the bottom, that's considered a unit rate. It's the cost for one item. Okay, so in this case, our slope, since it's 15 over 1, is the same as our unit rate. So then our unit rate works kind of like the rate of change where you're going to use words to describe. So you'd say $15 per, and then if I look at my X label, per 1 week, 1 week. Or you could just say $15 per week. Okay, so this time our unit rate and our slope are the same. All right, now I want you to look at this graph that shows the relationship between feet and inches. And I want you to find and interpret the slope, then find the unit rate and compare it to the slope. You have these 4 options. Good luck. All right, for this problem, hopefully you saw that we went up 12 and then we went over 1. So our slope is 12 over 1. And what that means is that there are 12 inches in 1 foot. Okay, so letter A would be your answer. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to our second example. Now we're going to practice comparing proportional relationships. So we're going to take this time to compare between an equation and a graph. Okay, so we have the distance y in miles that can be covered by a rabbit in X hours can be represented by the equation y equals 35x. The distance that can be covered by a grizzly bear is shown on the graph. So we want to figure out which animal is faster, and then we have to kind of explain how we know that. So if we start with the rabbit, so the rabbit, I want to know how far can a rabbit go in 1 hour? So I see hours are my x value, so I would say y equals 35 times 1, because I'm thinking about what's 1 hour. So I would have y equals just 35, right? So a rabbit can go 35 miles in 1 hour. Now a grizzly bear, if we look at this graph, I see that at the 1 hour mark, it has made it up 30. So that's 30 miles. So if a rabbit can go 35 miles in 1 hour and a bear can go 30 miles in 1 hour, which one's faster? That would be the rabbit is faster. And, you know, when it comes to an explanation, as we get to the homework and as we get to the review and test, I'm cool with like this sometimes just being your explanation, just showing me the different speeds very clearly, or the different distances very clearly. Sometimes, though, you're going to be asked how much faster is the fastest animal. So if we look, the rabbit would be we know it's faster because it can go 5 miles further. So sometimes you do have to explain just a little bit more, but the explanation usually can just be the work that I showed right there. All right, now here's the last question for you for today. We have the cost Y for computer repairs at computer access for X hours is shown in the table. Macro repair charges $23.50 per hour for computer repairs. Assume that the cost is proportional to the number of hours. So we want to know which company has the lower repair cost. Okay, so you need to figure out what's the cost of macro repairs, and you need to figure out the cost of computer access and then compare them. Okay? Good luck. Okay, for this problem, hopefully you saw that macro repair, we already knew how much they charged per hour. So I'm going to say $23.50 for macro repairs. And then if I look at computer access, I see that they start, with 2 hours. So I need to figure out what's the cost of 1 hour. So if I look at my table, I see it's going up by 25 every time. So up by 25. That means that in order to go backwards, I could just subtract that 25. So 50 minus 25 is 25. So that's how I knew that it was $25 per hour. Another way that you could do it is by dividing your y over your x. So you could have also said 50 divided by 2 and seeing that that gives you 25 or 25 over 1. Okay, so hopefully you said that macro repairs is the cheaper option. Okay, so if you have any questions about this example or anything else from this video, please be sure to reach out for some help. I am happy to help you. I hope you have a great day.